Hello. In this video, we'll continue to do a few more things in simple logistic regression. So first, let me read in the data set. And you can see it has fate as a dependent variable, Apache as the independent variable. We can fit a model, logistic regression model. And then this is a summary. And what about residual plots? Okay. Actually, the plot function still works. We can generate the 4 residual plots, which we have seen in the context of multiple linear regression. However, here they're not very useful because the dependent variable is 0, 1. Okay, so it's a discrete. So like a QQ plot doesn't make any sense. So what we do is we're going to introduce bin residual plots. So basically, this will be, we're going to bin in the predicted probabilities and values into different categories, bins. Okay, and then plot out the averages. For that, we need a package for the ARM. So I installed it and loaded it in here. And I'm going to use the bin plot function in that package. You can see bin plot fitted model, that's the fitted value, and residuals, type equal to response. Okay, and then the x lab, so the x-axis is the expected values, and y-axis are the average residual. Okay, you can see on the right-hand side, this is the bin residual plot. So the gray lines is the plus minus 2 standard error band. A good model fit should have a bin residual plot in which most of the data points lie within this band. So for this model, we notice that the lower expected values, there are a couple of points are outside the band. So there's some issues in that. Okay. All right. Next topic is the confusion matrix. As we know, a fitted logistic regression model can be used as a classifier, right? So you get the predicted probabilities, and if you use that, say, if it's larger than 0.5, you define it as a 1. It's less than 0.5, you define it as a 0. Then you get the predicted classification and compare that with the true classes in the data. Then you can actually assess the prediction accuracy. And one metric for prediction accuracy is the confusion matrix. And for that, we need to load in the library caret, and we calculate the predicted y and make it categorical, and make it a numerical vector of 0, 1s, and record all the true y's, and then we use this confusion matrix function. You must make this predicted y and true y into factors, okay, before this confusion matrix can work. Okay, so if we use look at the structure of this object, it has quite a few components in there. So here I just want to present the table, which is a 2x2 table, and the overall accuracy. This is the total number of correctly classified cases over the total sample size. So 84% is not bad. Okay. All right, so once you have a fitted logistic regression model, assume we have at least one continuous independent variable, then you can calculate the predicted probabilities, and that will become a continuous variable. So, and the dependent variable is a binary variable, so we have a continuous marker. We use that to classify binary outcome. In that context, we can create an ROC curve. So this topic is about ROC curve for a logistic regression model. Okay, and ROC curve is a very popular tool for assessing the prediction accuracy of a classifier. Okay, so we can do that by using our package called PROC, load it in, calculate the predicted y, get the true y, and just use the ROC curve, ROC function to calculate the ROC curve, and then just plot the ROC curve. Okay. And you can see this ROC curve is a little bit awkward because it's not sensitivity plotted against 1 minus specificity. It's just sensitivity plot against specificity. So it's a kind of a weird thing looking here. But there's another way we can generate an ROC curve, which is the R package ROCR. We load that in, calculate the we need to use the prediction function in that package to compare the predicted y and the true y, and then we need to convert that predict object into the ROC curve values. We put them into performance, the PERF object, and then we plot it out. And this is more of a normally looking ROC curve. So you can see it's between 0, 1 and 0, 1. So this is true positive rate, which is the sensitivity plot against the false positive rate, which is a 1 minus specificity. Okay. And as we know, the confusion matrix and the ROC curve for a logistic regression model, they are both called in-sample accuracy. So for any classifier or prediction model, we are interested in learning about the out-of-sample accuracy. Okay, so because any prediction model may have the overfitting issue. So we want to assess how generalizable of a prediction model on new samples. And for doing that, we have cross-validation. So this is cross-validation for out-of-sample prediction accuracy of a fitted logistic regression model. Again, we need to use the caret package. And here, let's set a random seed. And then we use the create data partition. That's the index for splitting the sample into training and test sample. We can look at the dimensions of these two data sets. So our data sets are very, very small. And then we need to specify the training control. Okay, so training control method equal to CV cross-validation, number equal to 10. So we're doing a 10-fold cross-validation. And then we just use the train function, give the model and the data equal to train. We're training this model on the training data set. And the training control is what we specified in the previous syntax. And method is the GLM and family to binomial. So we're fitting the logistic regression model. Okay, then we can print out the model and summary of the model. And now we need to assess the prediction model on the new data equal to test. Okay, so we still use the predict function, but now we're doing prediction on the new data set, the test data set. And then we need to convert this into 0, 1 and as numeric. And then we use the confusion matrix, which requires us to really convert everything into a factor. And this is the final result. You can see this is like unrealistic, so unrealistically good. But yeah, this is just an example here. Okay. Okay. So thanks for watching.